Alright, today's lesson covers geometric probability. I'm going to go kind of fast today, so please focus. First thing is the talk about probability. We have that term you got to know. You should be familiar with it. A lot of times we'll write something like A over B or A to B. And today we're also going to talk about making that a percentage. The key thing we have to remember is that the bottom term is typically the total. Not always, but typically. So when we're talking about geometric probability, what that could look like is a particular length over a total length, or a particular area over a total area. I'll show you what that means in this little picture that talks about length right here. If it talks about finding the length, or what is the probability that K is on CD, here's what you'd need to do. Think about how long is CD. A lot of times we'll give you a number, but in this case there's only the two letters. But then we talked about having the total on the bottom. So what's the total? It's A to B. So this would be the probability that K is on CD is this ratio right here, CD over AB. So a lot of times if they were numbers like 5, you could plug in the numbers. CD would be 5 units long, and the total would be 5 plus 5 plus 5, which is 15. You could simplify that down to 1/3, and you could simplify that to 33.3%. On example 1, we're doing basically what I just did in that example. They're saying, what's the probability that Fj is on Gk? So it actually is Gk on Fj, so be careful there. So the length from F all the way to J, you can actually count, or you can do some subtraction. If you want to count, that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 units long, and that's our total. So that Gk is the part that needs to go on top. The Fj is the part that goes on the bottom. So Fj on bottom, Gk on top. The length of Fj we already talked about. It's a total of 12. Now we can find the length of Gk and put it on top. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 over 12 is 3/4, and that simplifies to 75%. Example 2 is a little bit challenging because it involves some reading and comprehension. It says a shuttle to town runs every 10 minutes. The ride from your boarding location to town takes 13 minutes. One afternoon you arrive at the boarding location at 2:41. You want to get to town by 2:57. What's the probability you will get there by 2:57? I like this little timeline that they created because it shows a good visual of what's going on. The latest you want to get to your place, that final destination, is at 2:57. So that's your ending time. If you get there at 2:41, you got to figure out how much time you can wait before finally catching the shuttle. And if you miss that shuttle, that's a problem. So start off with understanding that it takes 13 minutes to get to town. So 13 minutes back from our final destination would place us right here at 2:44. So that means you only have this amount of time to catch your shuttle before you miss your destination. So how many minutes are there? That's 1, 2, 3 minutes before missing your shuttle. But how long is the maximum time that you would have to wait for the shuttle? It says it right here. The maximum amount of time you would have to wait is 10 minutes. So that's 3 out of 10 minutes that you can use to catch that shuttle. And that is 30%. So you have a 30% chance of catching that shuttle. On this next little part, it talks about ratios of areas. We already talked about ratio of lengths. Now we're talking about ratio of areas. So we're finding the probability that a point K is in the region M, this little shape. So what we would do is we would find the area of shape M and put that over the total. And the total is going to be area of shape J. For example 3, we're talking about a little golf course. They have a little prize. It says the golf ball is hit and stops on the green. The green is this larger circle. It says the prize is won if it stops in the painted circle. That's that white circle. So if you land in this small white circle, you get a prize. And the small white circle is on the large green. It says if the ball is equally likely to stop at any point on the green, what's the probability that the prize is won? So what we need to do is find the area of the small and put it over the total area. So the area of the small shape, that little painted shape, is going to come from these numbers, 15. But 15 is pointing at the center. That means 15 is the diameter. We never use diameter in a area formula. We use a radius, and a radius is half of that length. So what is half of 15? That is 7.5. That is the radius of that small circle. We need to do the same process for the large circle. Since the large circle's diameter is 75, we don't want the whole 75, we want half of it. And half of 75 is, give me a second to think, 37.5. When we find those areas, we get 56.25 and 1,406.25. Now notice, in this example, the pi is still there, so that hadn't been multiplied through. But what we've learned is that these pi's can simplify on ratios. And if you do 56.25 over 1,406.25, you get 1 over 25. So that actually simplifies to just 4%. It's a 4% chance that your ball is going to land on that little spot. So just think about this though. A hole on an actual green is really only like this big. So it's going to be even a smaller chance that you land and get a hole in one on a green. I'll give you a little bit to try these checkpoints, and then I'll go through them with you. All right, so on checkpoint number 1, it says find the probability that a point chosen at random on LP is on MN. So let's focus on this little piece, MN. How long is that? Well, they're counting by 2, so that's over 2, 4, 6. MN is 6. And how long is LP? That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So LP is 24 units. If you set 6 over 24, you get 1/4, and that simplifies to 25%. It's a 25% chance that you're going to land on MN. Now this one says refer back to the shuttle example earlier. In that shuttle example, you got there earlier at 2:41, but now it's saying no longer 2:41. You get there a little earlier. You get there at 2:38. Well, how many minutes early did you get there? You got there 3 minutes earlier. Well, if you think about earlier we had 3/10, but now we're not there 3/10 earlier. We're there 3 more minutes earlier, so we're actually there 6/10. So that's 60%. We have a much greater percent chance of getting there if we get there at 2:38. The last one is talking about the green, saying now you're trying to make it in the hole, and that's 4.25 inches. Now be careful, 4.25 inches is a different unit than what was in that last problem. The green on the last problem had a diameter of 75 feet, and now this is in inches, so we need to do some conversions. We got to try to get them in the same units. So I advise changing the 75 feet into inches. When you do that, you get 900 inches. So real quick, we need to find the area of these two pieces. The area of the small little hole is going to be pi 4.25 squared, and the area of the large is going to be pi, oh sorry, not 4.25 because that's diameter, so we want half of 4.25. So that's 2.125, and then for the large green, you take half of this diameter, so half of 900 is 450 inches. Then we can get each of those areas. So when we calculate these two areas, we get these two numbers. If we set them over each other, then we can see that that's going to equal about 0.00022, and if you change that to a decimal, that moves over 2 places, so that's 0.0022% chance that you're going to get a hole in one. On this last one, it talks about property, and we're trying to figure out what's the probability that we're going to land on grass out of the whole total property. So it says if a deer is equally likely to be anywhere on this property, on this graph, estimate the probability that it's on the grass. So we got to think about grass in comparison to the water. And this one, since they're kind of irregular shapes, we can kind of do a little bit of rounding because all it wants is an estimate. So what I would focus on is that the grass is right here. And I kind of see that that's a rectangle, so base times height. That's 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4. 8 times 4 is 32. So the grass area is 32. And then let's figure out what this water is. This kind of looks like a triangle, so I'm going to kind of round it up to a triangle a little bit. The way that I kind of envision that is if I take this little spot and this little spot, and they can kind of add up to that. It's pretty decent rounding. The area of that is going to be 1/2 base times height. The base is 8, and the height is going to be 3. So 1/2 of 8 is 4. 4 times 3 is 12. So what we can do now is figure out the probability of being on the grass, which is 32, over the total. The total came from doing 12 plus 32, which is 44. If we do 32 over 44, we get approximately 60-something percent. Let me calculate it. We get approximately 72.7%. Now this is just an estimate. Obviously we're going to be a little off on this space and a little off on this space.